Into it. Today, we're going to talk about one of the most powerful ideas in all of programming. And you know what? It's not really just about code. It's about how to tackle huge, complicated problems just by thinking small. So let's dive right in. So let me just ask you this. You ever stare at a giant project? I mean, it could be a massive piece of software, or even just planning a big event, and you just feel totally overwhelmed? Like, where do you even begin? How do you build something that complex without losing your mind? Well, here's the secret. You absolutely don't try to do it all at once. Think about it. You wouldn't build a giant castle out of one single massive piece of stone, right? No way. You'd use small, simple, easy-to-handle bricks. And that right there, that's the core idea we're going to unpack for programming today. Now, this whole building with bricks approach, it actually has a formal name. It's called modularization. So let's break down what that really means. At its heart, modularization is a pretty simple concept. It's just the practice of breaking a big, complicated program down into smaller, self-contained pieces. The key here is that each of these little pieces, these modules, has exactly one job to do, and it focuses on doing that one job really, really well. And, you'll hear programmers call these little code bricks all sorts of different things. Depending on the language they're using, they might say subroutine or procedure or function or method. But honestly, don't get hung up on the names. They all point to the exact same principle. One module, one specific job. Okay, so why do we even bother doing this? Well, it turns out that breaking things down like this, it gives programmers some serious superpowers. First up is something called abstraction. It just means you can focus on one tiny piece of the puzzle at a time without having to keep the entire massive system in your head. This is also what lets a whole team of programmers work on the same project. It's like a car factory, right? One person works on the engine, another person works on the wheels. They don't need to be experts in each other's jobs, they just need to know how their parts connect. And maybe the biggest superpower of all is reuse. Once you build a great module, say one that calculates sales tax, you can just grab it and reuse it over and over again. This is what we call the don't repeat yourself rule, and it's a huge time saver. All right, theory's one thing, but let's actually see how this works in practice. We're going to walk through the blueprint of a very simple program to really see this modular approach come to life. So here's our mission. It's super straightforward. We need to make a program that can take any two numbers and figure out their average. It's simple, for sure, but it's absolutely perfect for showing how these modules work together. Now, before we even think about code, let's just use our common sense. This problem really has three distinct jobs, doesn't it? First, we have to get the two numbers from the person using the program. Let's make a module for that and call it getInput. Second, we got to do the actual math. We'll call that module calculateAverage. And third, we need to show the final answer on the screen. Let's call that one printResult. See? That's our whole plan of attack. Okay, so this flowchart here, this shows us how the boss of our program works. That column on the far left, the one labeled main, that's our main program. And if you look closely, you'll see it doesn't really do any of the hard work itself. Its only job is to be the director, the manager. It just calls the other worker modules, input, calculateAverage, and printResult, one after another in the right order. So let's actually follow the action here. The main program starts, and its very first instruction is to call getInput. Now watch what happens. The flow of the program literally jumps from that main column over to the getInput column. That module does its job, it gets the numbers, and when it's finished, it hits that return step at the bottom, and poof, control jumps right back to the main program, which is just waiting for its next instruction. So we're back in the main program. What's next on the list? Call calculateAverage. And just like before, you can see the flow of control jump over to that module. It does its single focus job. Add the two numbers, divide by 2. Simple. Then it hits return, and control snaps right back to the boss, bringing that shiny new average value with it. And now for the final step. The main program calls printResult, and it hands over that final answer. Control shifts one last time over to this module, it does its job of displaying the answer for us to see, and then it returns. And with that, the main program's work is done. All its tasks were delegated and completed perfectly in order. Okay, so we've seen the visual blueprint, the flowchart. This is how a programmer actually writes that logic down. It's something called pseudocode, and you can see it's the exact same structure. That start and stop section on the left is our boss program, just making those 3 calls. And on the right, you can see the simple step-by-step instructions inside each of those individual modules. It's the same logic, just written out. But what if one of those jobs is actually Still pretty complicated. Well, the beautiful thing about this whole system is that it can go deeper. A module can call another module. The best way to think about this is like a chain of command in an office. The main program is the senior manager, right? It can delegate a big task, like get all the user input, to a team lead, which is our get input module. But if that task is still too big, that team lead can then delegate smaller parts of the job to individual team members. Okay, let's look at our pseudocode again, but this time with that chain of command idea. Take a close look at our get input module now. See how it's changed? It's not actually getting the numbers itself anymore. Now it's acting like a manager. It calls a brand new, even smaller module called get first value just to get the first number. Then it calls another tiny module, get second value, just to get the second number. We've just broken the problem down even further, making everything super clear and super simple. And that right there, that's the whole takeaway. Modularization really teaches us that there's no such thing as a giant, terrifyingly complex problem. There are only collections of small, easy-to-solve problems that just haven't been broken apart yet. And that kind of leaves us with one last thought. This isn't just a programming trick. Think about it. Think about a big project you have at work, or planning a vacation, or even just trying to learn a new skill. What's a complex problem in your life that you could conquer by breaking it down into smaller, single-task modules?